Here we are. Okay. Hi, everyone. Welcome to Unclouded. This is a new thing that we're doing where we navigate the frontiers of data, AI, Web3, and our journey away from the centralized cloud. I'm going to be your host, Carson. We're going to do this weekly. We did a few last year, and we're kicking it off again to kick off the new year. And we're just going to be exploring ways to reshape how we store, share, harness, and engage with information on the web and in our daily lives. And you can connect with us using our Telegram channel. You can follow and engage with us on Twitter. Whether you're like a tech person, an entrepreneur, you just kind of care about the future of data and AI. Hopefully you come to the right place, and hopefully you stick with us over the next couple of weeks. This week I'm joined by legendary Juan Benet. Juan is the founder of Protocol Labs and the creator of IPFS. If you haven't heard of those things, you're probably in the wrong place. He also developed Filecoin, and honestly, he's been kind of working to rethink how we all think about data and storage and the future of the web for a long time. And Juan, recently I was talking to a colleague of ours, and they kind of described Juan as someone who has a very sort of, actually their word is exceptional sense of timing in the tech world, and especially for Web3. Not a lot of people think in like next 1, 5, 10-year time increments and manage to keep that vision consistent and well-reasoned along that trajectory, which is exactly why I wanted to chat with Juan today about a bunch of big topics. So let's dive in. And first I'm going to say, Juan, welcome. Thanks for joining me. And this is a chance for you to say, I said all that sort of like nice glowing stuff, but you can tell people how you actually think about yourself.
No, thank you so much. And thank you for the super nice words. I hope I can live up to even 10% of that. I do spend a lot of time thinking about this sort of stuff. So yeah, very excited to chat with you. And yeah, very excited to explore all the set of topics.
Nice. So my goal with this, so my team was like, hey, do you want to host this unclouded thing? I was like, yeah, sure. Can I just invite a bunch of like my nerdy friends to chat about things out loud? And this has been like a thing I've wanted to do for a really long time. Is just like have a podcast or, Twitter spaces where just like a couple of nerds just talk excitedly about things that they care about. So we're just literally going to do that. This is like a conversation you and I are having, and we're just going to happen to have it out loud for everybody else to kind of like engage with and enjoy. So that's the goal. Two nerds excitedly talking about tech. So we can do that. And I want to know kind of like, what you think is next, what research and whose research you're reading right now. I know you're flying between spots lots, which means you're either watching lots of airplane movies, probably not, or you're like doing a ton of reading and writing. So I'd love to dive into like some of that stuff. I gave Juan, for people listening, a list of things that we could talk about. It's super long. No way we could get through it all, but we'll see how we go, because I really want to give us a chance to sort of explore and ramble a bit. But
on the plane thing, I do end up, I don't watch the airplane movies, but I do take a Vision Pro with me, and that has been an incredible experience, UX upgrade. If folks haven't tried watching movies or similar in a plane with a VR headset, it's just like a total game changer for long flights.
Really? So does it actually feel like you're not in a plane? Like, because my thing is like, I'm not really claustrophobic, but I almost am, and I can see that being a win.
I haven't tried the Quest 3, but the Apple Vision Pro like really does feel like you're totally disconnected from the normal environment. They did a pretty good job with the UX.
Nice. Yeah. I don't know if you ever watched Battlestar Galactica, but the robots, the Cylons, they were able to like project themselves into a different place when they were moving through their spaceships, and I was like, that would be really nice for airline travel.
Anyway. Yep. Yeah. And look, with time, as miniaturization of storage keeps going, like suddenly you'll be able to like take the entire library of the entire catalog of like all of the movies ever along with you.
If only we had a place to store that kind of stuff. Okay, so let's dive into a couple topics. The first one that a bunch of people in our ecosystem kind of are really interested in, well, everybody actually, everybody in tech is kind of interested in the future of AI and where all this stuff is going. So we'll start there because we would be remiss if we didn't at least cover that and dedicate some time to it. So this is like throw easy lob question. We'll start there and then we'll dive into some things. But what recent AI developments are you seeing? You know, like we're going to come back to the 1, 5, and 10-year timelines a bunch, I think. But like, what recent AI developments are you kind of particularly excited about? Maybe you can do it from a kind of your own personal vantage point in Web3, but it doesn't have to be. It can also be your perspective as just a scientist who cares about this stuff.
Yeah, it's a great question. So, and I'll caveat by saying that we could totally have a multi-hour conversation just on AI going in many different directions. So I'll give like the high order bits and then orient towards AI and data and AI and Web3 and things like that, and then maybe leave off like just a lot of the general things that may be covered elsewhere. The high order bit here is that deep learning really worked, and the scaling laws really worked, and people that were predicting that we would roughly hit human level intelligence between 2020 and 2030 or 2040 turned out to be right. And those predictions are pretty old. Like the very first predictions in that direction were in the 70s and 80s. Like the more credible predictions were in like the 90s or the 2000s. They were still seen as like pretty crazy. And when you look back in deep learning in 2010, 2014, the breakthroughs then were just getting the neural nets to finally start recognizing images, like just do basic object recognition, face recognition, and so on. And in a matter of 10 years, we've scaled that massively to that now be able to do extremely high quality reasoning. There's a lot of people arguing as to whether what's going to happen in the next few years and whatnot. But what is very clear to me is that when you zoom out of this and you look 5, 10, 20 years ahead, we're crossing the threshold of human intelligence now. If we haven't, I think we've already crossed it in a number of capabilities, in a number of topics. There are many areas where the current frontier models perform better than most humans, or like that randomly sampled human.
Yeah.
And so already the models are not yet capable of outperforming all humans at everything, but that'll likely. I just can't see it taking another 10 years. Right. If 10 years ago we were doing basic object recognition and now we're doing like extremely deep, high level reasoning, the basic scalability of what these processes, because they are growing exponentially, we should see dramatic capability improvements in that time frame. And the scale of the neural nets is now reaching the scale of the human brain. So we should be hitting way greater superintelligence in the next few years. So I really think it'll be somewhere between 2 and 5 years for superintelligence, not 15. And so I think like that is the highest order bit, which is like we're about to enter a world where we're creating a new set of systems that can reason as well as and better than humans in all kinds of ways. And the big question, or there's a whole massive set of questions, but like the biggest question will be, how does that relate to humanity in a huge way? Like, what does that do? We create a new civilization of people, a new species, or do we integrate that with humanity in some deep way? This is why I've been going deep into neurotech for quite a while now, which I think is like the integration path is a lot sounder and safer and so on. I think that again would take like an hour or two to like unpack that. But then separate from these threads, like there's what we should be getting ready for is that already today we have millions of LLM agents already processing all kinds of information and data and so on. These systems are already being integrated into all computing systems out there and all of the economy and whatnot. That this is going to continue. All kinds of like different systems and workflows will get revamped with greater and greater versions of intelligence. And this could have happened a different way, but the modality that we ended up with is one where we first do these massive training runs in massive scale data centers, and then we end up with an LLM in terms of a whole set of weights that usually fit in a few terabytes, and then you can run a bunch of these in single computers or small clusters. And so that means that you have the capability of running millions to billions of these very intelligent systems right off the bat, right? And so like as the intelligence capabilities keeps increasing, you now have like basically a fleet, or if we start getting ahead of it, a population of millions to billions of intelligent agents operating around the world. And the number is going to keep increasing. And so the vast majority of data that's going to get produced, transacted on, and so on will be through primarily different compute. I mean, already the vast amount of data in the world is generated and read by computing systems. But today, the intelligent part of that is humans looking at things. In the very near future, like that'll get eclipsed by AI systems. And as that happens, that'll open the door to all kinds of different systems and architectures and whatnot. Another angle on this is robotics, right? So the biggest problem in robotics was the software. We didn't have the ability to like navigate. Like, it turns out that the real world, navigating the real world is extremely complex. Like, our brain is doing an enormous amount of computation to make that happen, and it's just so intuitive to us. Like, we don't really think of it as like a super hard problem, right? Like you reaching down for that cup and like lifting it and so on is just such a like so much of our brain just is built to like operate that, and not just the brain but like the entire nervous system. And it just, because it wasn't a conscious action, we never really, or as conscious of an action, we never really thought of it as a hard problem. But it turned out to be extremely difficult, and that held back robotics for for the last 50 years. And sure, like there's a lot of like hardware developments and so on that's happening, but the biggest blocker was software. Like, we just could never get these systems to work well. And even like we used to joke that oh man, if like the robots ever start chasing you, just go upstairs. Like, there's no way they can like get up the stairs.
Yeah, nice.
And today, like the software for that is like super ready, right? And so that means that we're entering the landscape where we're manufacturing large fleets of robots that will be generating an enormous amount of data and transacting and interacting with all of these systems. So the internet's about to explode in terms of the generation and use and remixing of like massive data flows.
There's something really interesting there too, because we've been talking about like big data and like data explosions for a long time, and as you kind of alluded to earlier, there's like a lot of that has been either not captured because we just don't have like the capacity to capture it, or because we don't have the human intelligence, the human time to sort of like imbue that data with intelligence. So like the human was the sort of like limiting factor. There's always a human in the loop. Now we're getting to a point where, okay, sure, we're probably going to generate even more data. Not probably, we are definitely going to be generating even more data because we've got these AI agents that are, arguably like self-sovereign data creators, just like humans are, except that we can actually capture all of that data. But now we're getting to a point where we really better capture that data, because actually now we can imbue all of that data with intelligence. Like, someone can look at that data. It's an AI agent. Yeah. Whether it's the one that generated the log and is retrospectively like inspecting its own logs to see how it arrived at a particular decision, or another agent, like inspecting some outputs and like, enacting on that. We've kind of got to this point where like, actually we can process all of the data that we're producing and produce more, and like it's sort of exponential, but that's okay because we have this exponential growth in agent capabilities as well. So it's quite interesting, because it's like actually the data deluge might actually be like has been a problem to deal with in the past, and now it's like it's not a problem. We just have to build the sort of infrastructure to like allow us to process it. Like, someone's going to process all that data now. That's kind of wild.
Yeah, and we're also getting dramatically better ways of integrating and analyzing and extracting meaning and utility out of that data, right? So some of the really cool results include things like AlphaFold, which is now able to generate all of the different protein instructions and so on, and like the weather models, right? Like, people have been working super hard to build weather models for many decades, and it's
Forever.
been pretty crazy to see the latest models just like outperform all of these things by just like feeding the raw data into in the training sets into a model. The model like learns how to predict the weather, and like it has better accuracy than like all of the hand-tuned, like harder to build systems. And so like that shows that we'll be able to take extremely, and weather is like a great example because it's a super chaotic system and it's notoriously difficult to be able to predict anything. The forecasts are often with like such high error bars, and all kinds of like last minute things happen that end up going in a different direction. Like very low probability events end up happening, and this just shows that like tons of processes that up until today we haven't been able to wrangle are now within reach, and a lot of those systems haven't yet been measured. Like there's all kinds of stuff that like we just weren't thinking of collecting the data on. And so I think it's also an amazing time for like sensor networks around the world, like with being able to like get a sense of how the world operates better, and then be able to like have a dramatically better prediction model for like all kinds of systems, natural processes, or like behavior, all kinds of things.
That's, I mean, like arguably humans are good at navigating our environment because we have really great sensors. We have excellent set of sensors that we have access to. So like bootstrapping that whole sensor ecosystem and handing that over to, like, that's how AIs are going to explore their world as well. It's like through all these sensor
Yeah,
networks.
totally. And people often come up with this like, a lot of the conversation over the last 6 months has been, oh man, we're going to hit this data wall. Like the LLMs have already consumed all of the data on the internet, which is not true, by the way. Like they've consumed a lot of the text, but they haven't really consumed like just now we're getting the model straight on video and other things. But people forget that like, as soon as you have, think about how many cameras are out there. Think about like robotics, like you immediately can embody a lot of these systems and now generate/collect real-time data around the world, right? And so like the data wall is not like a real thing. It's just like now it's going to be more expensive to gather the data. It's just like, it's not like the data is not there.
Right. Yeah. Yeah, that's a good point. And that's a good sort of like maybe segue into some of the other stuff that we want to chat about. One is, we're talking about data capture a little bit here. I wonder, does this, like in the past, data creation has always come from like some human action, right? Whether it's like me going to a website or sending an email, or like adding a sensor somewhere, or whatever. It's always like evolved from some human action. We're getting now to the point where like we're getting AI maybe making decisions about where to place sensors or what types of sensors to like engage with, but also creating data, right? Like, and some people, you might refer to that as like synthetic data. But now there's like we're getting to the point now where there'll be no human in the loop once the loop is started. And so do you think that changes the way we like think about data collection, or is it still just bytes
Yeah.
on disk? And
Well, I mean, and this is where, I really think content addressing is the right paradigm for the long term, right? Like, and this is something that, when IPFS began, like, 2014, I had already been thinking about hash linking since Git, and since I had encountered Git and other file systems that were built with hash linking as a principle. And it just made a ton of sense for the future. It's one of those ideas that like, you're like, oh, location addressing is how we did things in the past. Content addressing is how we'll do things in the future. It just makes a ton more sense. And so I really do think that like, as this deluge of robotics and new sensor networks and new systems and all of these systems like grow and evolve and so on, making sense of all of these different disparate sources of data, being able to relate the data to each other and so on, is like a really big key problem. I think the current ways in which we organize the data, which, the dominant mode of this is, there's kind of like the web as like the main entry point for all of the data. And then beyond that, there's like huge databases and huge, there's massive file systems. There's of course like all of the long tail small file systems in everybody's small devices. But that model is just kind of like not the right model for the future. I think in the future, we are likely gonna be able to like integrate and fingerprint the data itself and be able to like relate the data to each other much more clearly and much more concretely. And that's where hash linking, I think, is like a key thing. And so whether it's like the current primitives that we're playing around with or a different set of primitives or whatever, or different systems, something is going to like pull these things together and create a paradigm by which you can produce data, move it around, find it, relate it, and then consume it and feed it into computation. And that is going to be more like data native than right now. I think right now it's very like location internet protocols native, where it's like, oh, you have to know where you put the data and you have like the right address and identifier and so on. Like you could be having the same set of data component, or like you may already have the data you're looking for in your own device or like in a device next to you, and like you shouldn't be like trying to like fetch it from like some server really far away, right? And so there's another case where as hardware, there's these like hardware scaling laws. Computing famously through Moore's law gets denser and cheaper. It sort of like doubles every 18 months or so, and storage does it like every 11 to 12 months. Like the last few years, last decade, hard drives haven't quite kept up with that as much, but like SSDs continue to have like this kind of curve. And what that means is like, and by the way, bandwidth is not getting nearly as fast, as kind of pervasive as fast, which means that over time, the storage capacity of every device just greatly amplifies relative to like the data that you can send between devices.
Right.
So that means you just like are able to just store more and more and more in each device. And so that means you want to replicate huge amounts of the data that you need, so that you're not like going around and fetching it all over the internet. You're like pre-locating it where you're going to need it.
Yeah.
It's going to become so cheap to like just carry around huge bundles of data that like, you shouldn't be going around getting it. I've actually been kind of surprised that like programming language package managers haven't really realized that laptops today come with terabytes, because you could just preload like huge sections of the package manager standard library in with like the first bundle that you like install or whatever.
Yeah.
And like you don't have to like take as long to install packages and whatnot.
Yeah, I mean, every computer, every Mac comes with like latest or some version of Python. Like half the Python libraries should just be there when you open up a laptop. Yeah, for sure. That, I mean, it's funny. It's funny that that's been the sort of like, because I mean, I guess at some point we start dealing with physics. You can only send things over a wire so fast, but you can like physically have something bigger and bigger and bigger, sitting next to you. So it sort of makes sense, but it's a disappointment of, I think, of like distributed computing, that it's like honestly still makes a lot of sense to store like a shit ton of data on a hard drive and mail it to someone.
Yeah.
Then
Well, that's going to continue to make like what I'm trying to say is like the bandwidth curve is improving slower than the storage density curve. So every year it's going to make more sense. So like every year, and this goes back to like the Tannenbaum claim of like, hey, never underestimate the bandwidth capacity of like a station wagon full of hard drives, or like full of tape, like speeding down the highway, right? And like that's a you load up a huge amount of data on like storage tapes and then you like drive it somewhere. And yeah, I'm kind of saying like that is just gonna amplify and increase. Like I think there are like a few moments where like this could go the other way, which is like, okay, fine, if we get full satellite internet connectivity everywhere, that like increases the bandwidth capabilities a bit. If we happen to get like massively better, like large wireless networks that kind of like meshed better, like maybe that could like change this fact a little bit, but it's only like a staving off the inevitable, like the ability to like to make smaller and smaller ways of storing and representing bits just means that you're just going to be able to like store vast quantities of data in very small spaces. And so that means like over time, the process of sending messages is really about like updating on new information, but you're going to have like very large copies of everything just kind of spread around.
That makes sense. It becomes a medium for knowledge sharing rather than like knowledge imbuing or something.
And it might change the paradigms of how systems work, right? Now today we do everything kind of like based on fetches, and it might change things to be much more push oriented, where like as you have updates, you like push them to like repositories, and over time these repositories like push the data to different locations. Kind of how CDNs work today. Like CDNs already work that way, where like as soon as there's some new thing that you want to distribute, like it gets pushed to a bunch of the servers everywhere, and like now they're like available locally. So just that, but like to the extreme, where that it starts getting pushed to you, like to your device at home or something.
Okay, speaking of paradigms, you can say that about anything, so that always makes a good segue. We've been talking about AI, we've been talking about data. What we haven't touched on yet is like why Web3 and why crypto. And I actually just saw a tweet from the Near folks, and it was like, why a lot of people are asking like, crypto is talking about AI, but why isn't AI talking about crypto as much? Because, and so that's a big question, but like there are some things that we kind of know implicitly in the crypto and Web3 space that we offer to the whole AI ecosystem. And maybe we've been not that good at selling it because we're at the same time selling Filecoin, but there is definitely like some benefits, to the space. So like what can we do? What do we offer AI in the crypto space that it can't get elsewhere? And then maybe a sort of like corollary of that, because I do want to talk about Filecoin and meme coins and funding in a sec as well. But a sort of corollary of that is what is holding like blockchain tech and things like that back from being the medium or rails upon which like all of these AIs are engaging?
Yeah. So your question, good set of questions. So I think the reason why we haven't yet seen these stacks merge, and here by these stacks I mean the Web3 stack and kind of like the Web2 stack of traditional cloud and so on, is because the Web3 paradigm is just so different, and so it changes so many of the underlying primitives that it's kind of like hybrid adoption is like not quite as possible. And we also haven't finished the producing such better UXs for the world that the large sets of users in the Web2 world should like migrate over now, right? So I think it's partly like, hey, we're trying to rewrite a lot of how everything works, and so there's like a very large set of tasks that have to be completed. And then second, the UX that we've produced along the way just isn't that good yet to get adopted at massive scale. Now, the adoption is happening. Like you can see it in like all kinds of charts and all kinds of numbers everywhere. Like adoption of these new primitives is happening, and it continues to grow and speed up. It's just kind of happening slower than everyone kind of wants it to, or like slower than folks expected. Maybe there are parts where like there are really interesting intersection points of really high value. So one area that I do see AI people talking about crypto is in using the proof paradigm to be able to like start proving things about the models. So that means being able to have provenance of the AI model. That means like provenance of the data that was used to train it. That's provenance of the model weights itself. Like if you do any RLHF type of alignment things on top of a base model, what happened? And then provenance over the inference queries that you might do. Like you might want to be able to track what these queries were, who made them. You might even want to introduce policy decisions in between, or you might be able to then do more interesting algorithmic things, like being able to prove something about what the inference query might be about ahead of running it. So even before you run something, you might want to like be able to detect, or have you can imagine a world where you have a super capable model. Before that, you first ask a smaller model of saying, hey, is there anything like is there kind of like anything inherently unsafe about running this particular query or this particular prompt? And you kind of like can get a score, and then based on that, like you can decide whether or not to run the full thing. So you can come up with all kinds of governance structures around these LLMs, and you can use the cryptography and crypto and blockchain tool chain to be able to like reason about this better. One group that I've seen do really good on this front is Equity Lab. Like they've been producing like extremely interesting, very high quality like provenance structures for AI models, and they're just kind of like ahead of the curve of like wherever a lot of other folks are. The other area where I see AI folks talking about crypto is that, and this is, in the early days of crypto, we were talking about this, like as soon as we saw that you could use cryptocurrencies to create like kind of magical internet money and be able to like have money accounts in a kind of like digital native sort of structure, which is inherently different than the current banks model. The current banks model is not digital native. It's like normal account book paper native, and it got sort of like ported over to the digital world, but there's still all these like layers of traditional structure in there. When you have like a fully digitally native system, that means that AI systems and AI agents now can start interacting and transacting with money and with other rights. Like you can encode specific rights as capabilities, like concrete, a specific capability is a cryptography term where you encode a specific ability to do something and you put that within a cryptographic key or some kind of like access pattern like that, and you now can imbue agents with very concretely well-defined, fine-grained sets of capabilities of being able to like interact with the world, and you can create a paradigm for those things to exist in this kind of cryptography blockchain first native way. So the area where I do see a lot of like AI people talking about blockchains is like, oh yeah, like the paradigm for AI agents to exist in, like once you start thinking about these things as having their own agency or the ability to have rights or the ability to have contracts or the ability to like interact with people or control money, now in blockchains. And it's not just that people are talking about it. There have been already several cases of like early stage LLMs that have been kind of like sort of let pseudo loose on the internet, like not exactly loose, but like Truth Terminal is maybe the best example of this, where like Truth Terminal is like an account on Twitter that an LLM controls, and it like messaged Mark Andreessen, asked for some money, got some money, then like launched a meme coin and so on. And like immediately what this LLM figures out like the easiest thing to do, and like in terms of like growing its capital base and being able to like access money and access things, is that the crypto paradigm is just like a lot more convenient and easier to use than like the traditional banking system, right? And so like that's an example of where these two worlds will meet. One idea that I've been like very nurse-night by and thinking a lot about recently in the last year is I think it's finally time to create a kind of like jurisdiction or structure for AI models to get like something akin to personhood, where you can like start interacting with participants and expressing actual contracts. So like not just smart contracts, but like enable LLMs to like transact with each other or transact with people, and have like a legal like computable structure on top of that. Like if you had like a jurisdiction where AI agents can like be their own corporations and interact with other participants and whatnot, have a notion of legal personhood. What does that look like? How do they interact? How do they work?
Right.
Like, what are like the rules of the road for that? And I think my prediction is like,
if you've got a digitally native being, then you kind of need a digitally native, jurisdiction for them within which they can operate. Because otherwise, it's sort of like we're going the opposite direction. It makes a lot of sense, right? It's like I create this purely digital being, but like they're bound by the rules of like the province of British Columbia, a geographically bound place. That's pretty strange, actually, if you step back
totally,
like even a little bit and think about it. Yeah,
totally. And so I think like these kinds of spaces and environments will emerge, I think, this year, could take to next year. I just don't see. I don't see us waiting until 2027 to like deliver this sort of stuff. And so I think like we will likely see the first networks of AI systems where AI systems are starting to interact and transact with each other and with people, like probably this year, maybe next year. Which I think will be really cool. Like pretty,
yeah.
Like will explode all kinds of like interactions, all kinds of like positive upside and like risks, right? Like so I there's a lot to like be super excited about and look at as very optimistic. And there's also like a lot of ways in which like this can go wrong. And so I think like one really key thing though is that I do think that we need to experiment with all of this stuff as soon as we can in public and before these models get a lot more intelligent. I do think that in the end, OpenAI has been very right about you want to like deploy these things in production and enable a lot of people to like adjust and understand what's going on as soon as we can. And so like as soon as that capability like frontier opens up, you want to like test the hell out of that right now while the models are not nearly as intelligent as they will be, right? And so you don't want to find out that like you have, you don't want to have to like figure out what are like the right rules of the road for enabling AI models to interact with each other and with people when the models are like vastly super intelligent. You want to do that now,
right.
when they're not.
And that's a pretty good example of sort of like Web3, like crypto ethos kind of at play, right? Which is, the whole industry is like DeFi alone is an example of like actually experimenting out in the wild, like in production, like all the time, has led to some pretty interesting, like it's led to some, terrible outcomes for certain people and some, arguably outsized great outcomes for other people. But it's also allowed us to like iterate on financial systems and like incentives so much faster than like ever before, because we have this little like experimental environment to play around with. And I, it's going to lead to probably some regulatory action in the future, because we're like, oh yeah, wow, if we just let that go rampant, then this bad thing happens. But I think it could lead to some deregulation as well, where you're like, actually, if you let people go hog wild, it turns out, they just kind of like optimize for this reasonably good outcome. Like we can experiment and iterate quickly, which is interesting because that's another thing I wanted to chat with you about. Since the new administration in the U.S. has like been announced and seems to be a little bit crypto friendly, we have seen this crazy explosion of experimenting in production live around like meme coins and AI coins and like these different platforms that are just like skyrocketing. And the like old 40-something in me is kind of like, oh, this is terrible. People are going to lose their money and it's very scary. But the like optimistic tech person in me is like, whoa, this is like experimentation accelerated. And maybe there's some sort of like future funding model hidden in here somewhere. And so I'm wondering if you have any kind of thoughts, as someone who, you were there in 2017, where the first like crazy explosion of crypto investment happened, and you've seen things come and go, and now we've got another explosion, arguably. Like, what do you think?
Yeah, it's a good set of questions. Like, I am, when I look back through the last few years in crypto and Web3, I am frustrated that the level of utility that we've created for the world is not way larger yet, and that a lot of the like look, I think meme coins are like can be really fun and like exciting and can bring communities together. And part of it is some of them are like very entertainment oriented. Some of them are actually trying to bring together a community to do something, which is pretty cool. And so like I have like nothing against meme coins, but I do think in terms of distribution, I do think it's a bit off if like the biggest thing that's happening in the industry and that a lot of people are talking about it is meme coins, or it's kind of like the broader casino investing culture. I think like that has more to say about like, hey, when you have a super liquid financial environment, And when building things is really hard, because it still is pretty hard in crypto, then this is kind of like what you're going to get. So I think it just has more about like the things just being still pretty hard to do. So that means that a lot of us have a lot of work cut out for ourselves. But I do think that like there's super interesting things going on. So like I think, for example, like the AI 16Z stuff that's happening, I find like pretty cool and pretty interesting. Like that is super fascinating in terms of like the opening up the possibility space. It does feel like a bit like another kind of like boom in being able to like coordinate a lot of people to like fund specific things and grow them and whatnot. I haven't yet seen it channeled for super valuable stuff yet. But I mean, like the 2017 was like the big wave of ICOs, but there were a lot of ICOs for many years before that, right? Like Ethereum was in 2014. Even Ethereum wasn't the first one. There were like several others before that. There was like Mastercoin and other things. I don't know if Mastercoin did an ICO, but like there were like a number of things like that in 2013, 2012. So it took quite a while for those things to like get productionized, and you really needed a platform like Ethereum to exist to then be able to like do them at scale. And a lot of people look back to the 2017 period, 2017 2018, when kind of like there was like a ton of ICOs and then like a huge ICO bubble, right? Like there were a lot of like legit ICOs, and then later like there was like this kind of like bubble effect. And if you actually go back and do the math, because I've kind of like done this, which is kind of like surprising to me, the industry has returned many times over. Like so the industry kind of like all the ICOs that were like kind of like tracked raised on the order of like $29 billion worth of capital in like a year and a half, which is staggering, or like enormous. This is kind of like this larger than like many years of venture capital in some cases, and so it just shows the potential of this kind of technology, of capital formation technology. But the surprising thing is that the industry returned that many times over. So if you just like indexed all of it, including all of the crap and all of the like bad projects, you still made money, which is crazy to me. And so that suggests that like you could have those kinds of environments with a bit of signal processing, of like actually being able to distinguish like what is the signal, what's the noise, and like be able to like have a lot more like clarity over like what the community thinks are like real legit projects and what's not, and end up with like a dramatically better fundraising structure than what the world has today. I think it's a huge disappointment that like I think crypto has not kind of democratized capital formation more up to now, given that like we have the tools to do it. I think maybe with this different regulatory environment, we're going to be able to like bring that back. I think things like AISNTC are pushing in that direction, and they're not like adding the twist of like interconnecting it with LLMs and agents and so on. I do think that as soon as we have some structure for LLMs, for AI agents, so the thing that people call AI agents today, I think is different from like what I think of as AI agents. Like people tend to think of like work processing workflows as agents, where like they describe an AI agent as a thing, like a little kind of a way of connecting an LLM tuned for a specific type of job or task, and then kind of creating like these like workflows or like networks of these task processor components. And that's kind of like what the world has called like AI agents. But I think that's fundamentally different from, hey, what happens when you like imbue an LLM with like its own notion of agency and its optimization function and like some way of like navigating the world and environment, and like you kind of like enable it to like go figure it out. And so that, when these are like they have like their own sense of operation and can like be in this long running mode and whatnot, closer to what Truth Terminal and other things are doing, but like, maybe a more extreme version of that. I think that has massive capability, can open the door to like just the economy growing a lot faster in a bunch of ways. Now, again, we have to like be careful here, because like that's, this is how you get like rogue optimizers. But I do think that like we have to figure out how to do this right, and how to integrate the AI models and humans and human organizations in like a very cooperative, positive sum oriented game. Like, and we have to figure that out now. Like, I don't think this can wait like 4 years.
Yeah, I mean, it's interesting because one of the things I am like really excited about in this sort of like Web3 world that I think was a really exciting application of like a lot of the different features of Web3. It didn't need to exist strictly in Web3, but it did, which is the betting markets and and it's sort of like coming together to predict like the betting or prediction markets. Prediction markets is like the thing that's actually interesting, right? Because there's so much interesting like tokenomics or just incentives and like it's this perfect, well, perfect in a market sense, like information aggregation framework to decide what's good and what's, like we can make sort of like fairly, human-like decisions, or at least make human-like predictions about like what's going to happen this way or the other way. And we can aggregate all this information that all people have about perspectives of whatever. And that can be for, that could be driving AI as well, right? Like we can, like the AIs can say like, look, I'm trying to make a decision. I want to, allocate funding for this cause or another cause. Let's bring humans and AI together to like, make a decision in an open Web3 Rails framework and do that together, or decide what AIs get launched. And there's lots of different ways where I think like we could be a lot more responsible with the cool tools that we have to lead to good outcomes, as opposed to Filecoin and things like that.
I think I find prediction markets a great example of like a technology that is super powerful. You can show it has tremendously positive applications, and one that like got held back by bad regulation. So kind of like prediction markets have been were invented in like the 80s, 70s, maybe earlier. I think it was 70s or 80s, and they were deployed in very like there were a lot of deployments over the decades, but they were like deployed in very limited settings because they weren't really allowed to become like a public mainstream thing,
right?
Because they sort of like got classified as needing like all of this deep regulatory oversight. And I think this was like CFTC maybe, but they were just sort of like hampered. And so all of these kind of like really neat applications of prediction markets were like, hey, you could use prediction markets to decide like scientific funding. You could use prediction markets to like figure out like hiring and recruiting at scale. Like you could use prediction markets to like do venture capital. You could use prediction markets to like do like policy setting. Like you can use prediction markets combined with governance structures to produce a thing called futarchy, or other kind of like governance mechanisms. Like all of those like really neat constructions and ideas effectively had to wait until the crypto world kind of like busted through regulation,
I guess,
to then kind of like come along with us, right? So a lot of those ideas and applications were proposed, and again, there were like limited examples of these deployed, but they never like really changed the world yet because they're not like easily accessible. And crypto created a paradigm where they suddenly became like worldwide accessible really easily. And I think it's like super fascinating. I've been very excited to talk to many groups in the last year or two, working on using prediction markets for finally like governing groups, like and deciding on like policies for like DAOs and policies for blockchain protocols and whatnot. And like it's a perfect application for it, and I think it's going to be like really, really exciting.
Nice. Yeah. Okay. All right. I'm gonna change tact a little bit, and this I'm watching our time, and I want to make sure we get to as many things as we can. So we've done AI, we've done blockchain, we've done crypto, we've done meme coins. Now I want to do more like Juan stuff. So I'm gonna queue us up, and then we can go through questions one at a time. So I'd love to hear about sort of like what's on the horizon for PL over the next couple of years. Are there any sort of like new tech or projects that you're sort of like hyper focusing on? We can talk about a little bit of that. I definitely want to make sure that we leave some time for the pop-up city initiative that you were involved in. I think a lot of people would be pretty interested in that. And then because this is two nerds talking excitedly about tech that they care about, what's like Juan's next side project, or like what's the sort of like next little thing that you're interested in? Because you wouldn't be an engineer if you didn't have like a secret side project that may never see the light of day, but you're excited about.
Too many side projects, and I have like the bad, maybe great habit of like turning side projects into main projects like pretty pretty quickly. I get like a lot of people are surprised / annoyed at like the rate at which I create projects. I really need to like. By the way, this is where like LLMs are going to be so helpful. Like suddenly I'm going to be able to like just start up a lot of things. But anyway, like so maybe like the main thing that I'm just super excited about is to like finally be able to orient PL, like Protocol Labs, towards like the core problem that I started PL for. So when I started PL, and just for context for folks that are unfamiliar, Protocol Labs is a network, an innovation network of 600 organizations, primarily startups, that are pursuing all kinds of like different goals and missions, but that are sort of like brought together by a set of like common structures and principles. And today, it initially started as a single company, and we developed things like IPFS and Filecoin within PL, and now it's a pretty large network. Is like more decentralized and pretty, has like kind of like a layer of infrastructure where like there's a set of companies that are working on building infrastructure for everybody else. So this is kind of like shared events and like communication channels and other kind of like systems, like communication systems to enable like participants to help each other. And then there's like a set of components around like capital. So that means like either venture capital. So this might be investment for startups, or it might be impact capital. So this might be grants and grant funding for early science or open source software that like just can't really be monetized in some way. And so there's kind of like all these like sort of like different components in the network. And I started PL initially to sort of create the institution that I thought was missing in the world, where like when I started thinking about IPFS and trying to go build it, I was looking around for somewhere I could go to like develop it. And if this had been the 60s, like 1960s, I could have just gone to Bell Labs, and like that was like the right place to go do this. But that doesn't like really exist anymore. And the current large scale corporations like Google or Alphabet and others don't quite house or home projects or initiatives like this with their own kind of like same degree of agency and ability to like flesh out and develop and whatnot. And they don't really invest as deeply in like very early stage basic research or foundational tech development. And so I kind of like saw this, like was very kind of frustrated by like this gap or this hole. And I'm not the only one. Like there's a lot of people that shared this frustration in like early 2010s, like 2010, 2012. I used to have like many conversations and groups of like there was kind of like this like group of us who pined for the days of like Bell Labs existing. And the kind of like the thing that the thing that I wanted to build with PL is like some kind of organizational structure, some kind of like institution that could enable that long-term R&D process to happen with a lot of individual agency on a per researcher or per project basis.
Mm-hmm.
And the components that you need for that are like, you need some amount of like, you need like a research community of some sort. You need a kind of like connectivity to capital and resources. You need some way of like marshaling and attention and being able to like gather a set of participants and groups to like help you. And like we're kind of like putting a lot of those structures in place. And maybe the core thing that we kind of like now centered on is there's this fundamental problem in how R&D gets funded specifically, where it gives rise to what's known as the value of death in the scientific community. So like this means today we have good capital structures to fund product development. So once you have a good product idea and there's like a strong business and whatnot, you can usually find a good way of like getting that funded through very early stage angel investments or accelerators or eventually venture capital and so on. But and also if you are working on very early stage science, so like very basic research sort of stuff like in deep physics or biology or something like that, there are government agencies that are giving a lot of grants and universities where like you can go do that work. And right. It's not ideal. Like all scientists hearing this probably agree with me that like they know their field is like vastly underfunded and they would like more funding to go towards it. And you can think of like tons of projects that like need more funding. However, the part that's downstream of basic research, which is a part that allows you to call fundamental development,
Right.
that part is deeply underfunded. So that part is way more capital intensive. This is before there's a product or a business and so on. This is when you're doing like so you've had the core scientific insight, you've published the paper, and you now like want to figure out how to generate applications.
Right.
And there's usually an enormous amount of work that has to go into that phase, kind of like in maybe, famous like invention terms, like, if you think about the transistor, like maybe the basic research part was like the statistical, physics, solid state physics work that led to like making the very first, ideas of like actually what a transistor could be, and then like the first actual like prototype invention, like the model, the first device of the Shockley and Breton, the Shockley group in Bell Labs made was like the first invention, and like that's the paper, that's like the Nobel Prize winning result. But going from that to, okay, great,
Right.
you have transistors in a product, requires like years of hard work and development and deep R&D on like making that thing smaller, figuring out what materials you can make it out of, how to make it small enough, how to produce it, how to manufacture it, and so on. And that part is like deeply, deeply underfunded in the world today. And so today we have like this oversupply of ideas that have been discovered. So like science has gotten ahead of the things we can use. And the bottleneck is really on how do we translate what we're discovering into good solutions. The parts of of science that are translating the fastest are the ones that have found such a large-scale successful financial application that you have massive corporations funding the research. So
Right.
that, for example, semiconductor development, like there's massive amounts of basic research that is done in semiconductor physics that is all funded by the semiconductor companies. There's, like all of the all of the AI development that we're seeing today, like that's not like zero of that, or like very little of that is nation state agency funded. Most of it
Right.
is like corporation funded, because it's very direct connected to applications and products and whatnot. And so there's all kinds of areas in science that like are not translating, and they're not translating yet because there aren't large pools of capital able to fund that part, that fundamental development part. And so what I'm pretty excited about with PL is like figuring out structures to do that. And so there's like one part of the answer, which is kind of like coming up with new earlier stage versions of VC that could like take way bolder risks by having like longer term fund cycles. There's other structures where you figure out like much more specific, like you try to like appeal to specific governments to fund that part of the pipeline, or you like don't wait for government to do it. You just go and fund it philanthropically or with donations yourself. Or you can do things like what VitaDAO are doing, and like the DeSci, like BioX, and there's a number of like the DeSci communities like going wild on this, which is really awesome. Where like they're creating a good funding paradigm where you can fund basic research, you get IP out of that, so whatever like the research produces turns into IP that like the DAO gets, and the DAO can then sell that IP to corporations, and like that
Right.
that is like a super good construction that I think could like work for this. But then there are other ideas, like you could create new investment contracts that like can do the like, if instead of like waiting for an exit, it translates into like producing IP. By the way, I don't love that there's patents. I am a very kind of like open source, traditionally anti-patent sort of person, but like I do think like you kind of need some structure or some asset or some right to be able to like fund this part of the pipeline. And then another idea here is like using things like drips or other kind of like credit assignment models where you figure out like the trace of contributions to then be able to like fund it retroactively. And so like retrospective funding is I think a super cool structure that like if we can like make bigger and scale, I think could be very successful here.
Yeah, I mean, a sustainable retro funding mechanism is like really what you want, right? Because then people can start to like foot those upfront costs in anticipation of like, look, if I do a good job here, I know there's this funding that's available, and I know I'm not guaranteed to get it, but I am like, I know it's going to be there. So if I do a really good job, I'll have access to it. Whereas the upfront funding is, is a little bit safer, I guess, in terms of like actually developing things. As a former academic, like all of this is extreme, like very close to heart. That that sweet spot that you're talking about, like from basic research to like there's also a skills and like expertise window that's very small, right? Like there's a lot of people who care deeply about like deep, like computer science or like physics or chemistry, like these deep problems. But, like when I was in academia, we actively discourage like writing software libraries to implement your statistical method. Like that was not a good use of time. And so there's a lot of, I mean, just so we're clear, I think it would have been a good use of time, but for some reason, like, funding and like incentive structures for, like early stage academics is not writing software libraries because you get no credit for that. But like there are a bunch of people who have like deep knowledge of science and can write really good code, or can, like bootstrap a chemistry lab and actually like implement, like those people are out there. But yeah, like that's not only is that sort of like a skills issue, but that's probably the most expensive thing to fund, right? Because you can do a ton of theoretical work over here with pen and paper still, and then when the rubber meets the road, like you got to build a lab, or you got to,
Yeah, that gap is something that I think most scientists don't realize is so big. Like most scientists tend to think of like, hey, there's this extremely hard and capital intensive process, which is kind of like coming up with like do all of the research down tons of paths that are not going to make it, like figure out all the dead ends, and then find the right result and the right discovery. And that's a very expensive process, and it's expensive in time and in money and like in all the things. And then they think that, okay, great, like once you have like the result, then kind of like, eventually like the world will just make use of this and it'll get put into a product, and like that'll be sort of done. Now in reality, like for there to be a business there, the result has to be translated into something that can be easily put into a product and then scaled. And the process of going from research result to that business component, by my estimation, is somewhere between 10 to 100 times bigger, more expensive than the original kind of research process. And I've looked at a ton of data on this, and like, even the labs who kind of productionized this the best was usually kind of like had teams much larger, around 10 times larger than they were kind of like productionizing all of the stuff. And so that process is dramatically more capital intensive and is currently not funded by VC for the most part, and it's not funded by governments at all. Some VC kind of like dips their toe in there, especially with like the right founding team and like the right credible founders, because you take such level of risk that it becomes kind of negative expected value if you invest too deeply into like the fundamental development stage with like a 10-year fund. But there's like no government funding in that spot, and so I think like that, like the reason your lab just couldn't afford to enable you to go and like write your software library is just like, they're under like severe capital constraints and time constraints. And then if you just write a paper, then no startup can like really dig into it and use it, because like they cannot afford at all to like go and begin writing that library and whatnot, right? And so precisely like building software libraries is that kind of fundamental development piece that we need to get like funded somehow. So this could be creating new forms of like academic credit for it and government funding for it, or it could be longer VC timescales, or it could be fixing IP. Like my one of the opinions that I've had for a few years now is that maybe one solution to this might be fixing the IP structure. Like IP today doesn't work as a revenue source because it's like a kind of like a toxic asset and like a toxic transaction that nobody really wants to be a part of, and it's like an awful kind of like transactional experience. And to me, it kind of is this idea I had like a few years ago, but like that I haven't like really pushed on. But like to me, it seems kind of like an Airbnb style problem. If you remember the days before Airbnb, the idea that you were going to go and stay at a random stranger's house and stay in their living room or stay in like their spare room or in their apartment when they're not there, like that was like strange and weird, and like it happened. Like if you had a friend of a friend and so on, like you knew that this was possible. You knew that this could be done. That people did do it, but it was like very cumbersome and laborious and like just usually negative expected values. Like most people didn't do it. And all it really needed was a great set of designers who looked at the problem and designed a very high quality user experience around it and structured the market. Like they structured the transaction. So they restructured the idea, they restructured the transaction to make it a very simple process where like, hey, you have a website, you like look up all of the listings are in high quality, you press a button, you've booked it, there's good standards, there's a review system and mechanism to make sure you have a good experience, and it's very close to a hotel. And like, wow, like that was like transformational for like hundreds of millions of people worldwide. And so my sense is like IP and patents could go through a similar transformation. It could be that like we're missing a marketplace type structure or some other kind of platform, and a different way of packaging a transaction so that it does not produce these like very toxic assets. Like it's kind of a problem that like you can patent a thing and inhibit like the world from using it. Like the fact that you can patent a drug that might save billions of people's lives and like you can prevent governments from making it, like that's crazy. At the same time, you can't just make it effectively used for free because then like nobody will like do the early research. So you have to square that problem by then maybe saying patents must always carry a fair market value price as assessed by a market. And there's always a transaction and it does not require the approval. It's just like whatever the price is, anyone can buy it. And like if you create like structures like that, which you could do with crypto, suddenly maybe that entire structure could be developed. So yeah, I don't know. It's like a bunch of like ideas here that I think more people should explore.
Nice. Okay, cool. Now I know you said we can go over a little bit, so we're gonna do that because we've got a little bit of time. But what was the other thing we want to talk about? Yes, the pop-up city initiative and some of that that type of work and stuff that you've been involved in.
Yeah, totally. So this is kind of like, maybe I'll describe sort of where this came from for folks. So let's start two angles. So one angle is a lot of us had great experiences by getting to meet and get to know people through universities or hacker houses or like co-living structures or conferences or events. These kind of like ways of gathering people for extended periods of time produce like these super high quality ways of advancing your thinking and your development and so on. And there seemed to be like missing a structure somewhere between like longer than a conference but shorter than a university, right? So like longer than like a few days or a week and shorter than a year or something like that.
Yeah.
And then from a different angle, biology has been pushing the idea of network states for a while. And the idea here is that, hey, ever since the 19th century, when kind of like land all sort of got spoken for and the balance of power in the world, we sort of like tried to like reduce like wars of conquest and like inhibit like this like bad source of history. We've also, as a consequence, disabled the ability to create new countries. And so when new countries happen, they usually happen by a country splitting up that had disagreements, or basically that's kind of like the main process that it happens now. And it's usually like a very like tends to be kind of like not exactly like a super positive avenue because it's usually some like very big disagreement. And historically, societies have needed a way of like banding together with a new set of ideas and a new set of like principles to build a society together. And now that you don't have land, you can't quite do that. At the same time, the internet maybe opens up the door on that and says you no longer need land to get people together and kind of create the notion of a country. And that's where the nation state idea comes from. And so biology has been pushing this idea that like, hey, groups of people that think structure should be different could get together online and go from like traditionally what would be an online community into something much bigger that carries more weight, where you start creating a notion of a network state. Nice. And then over time, you may be able to acquire or buy land or get sovereignty or whatever. And I find that idea like super important. It's one of those ideas that a lot of people may maybe find controversial or disagree with and so on. But I really think it's important to the development of humanity because there's like governments are like any human organization. They develop craft. They develop laws are based on like old time precedents, and so usually you like throughout history, major advances have come from at some point people creating a new place where they can try things from scratch and like just kind of like wipe the slate clean on old laws and old systems and try a new stab at it, right? It's kind of like starting a new code base in a sense.
Right.
And we need that kind of structure, that ability. And so like the network states movement and kind of like the public cities movement sort of began around these kind of like ideas of like gathering people together to interact and grow together and kind of like live together in the same place for a while, especially now that everyone's very online and traveling and whatnot. And then the other idea is like, hey, maybe you could like create a new way of like improving government structures. So that had been happening for like a couple of years, and recently, so last year, some friends and I realized that Argentina specifically has massive crypto adoption, is a super talented place. Like it just kind of like punches way above its weight by population size in terms of like super skilled people, like very deep in tech, and has had like tragically a really bad history of economic mismanagement for many decades, right? So like it started in the beginning of the 20th century, so like 1900, Argentina was one of the top 10 countries by GDP. Like people don't really know this. It's like it was like right up there with the US and with many other like European nations. So unfortunately, in the 30s, 40s, 50s, it just had like a slew of bad economic structures that like sent the country on like a downward trend for the rest of the 20th century. And it had periods of recovery here and there. Like there were some good sets of years and decades, but for the most part, it's been kind of like falling behind. And despite that, Argentinians have been deeply talented, super entrepreneurial, have built like incredibly valuable inventions and companies and so on around the world. And in the last few years, because the economic structure in Argentina was so bad, and there had rampant inflation, like we're talking about like somewhere between 100 to 250% per year, which like all of the U.S. and Canada and Europe was freaking out over 15% per year inflation, right? Like, which was like a lot, but like that was like an enormous amount of inflation. Now imagine 150%, like 10 times worse.
Yeah,
you start hitting like hyperinflation territory, right? Like you just can't save. Like you make money. Like there's no sense of like saving for the future. You can't like put your kids through college with funding and so on, and you can't like really move. You can't buy houses. There's no mortgages. Like all of this like basic economic building block sort of stuff was missing. And so kind of like two big things happened. One is massive amount of crypto adoption, right? So it was like a huge testament to our industry actually producing something of like great value, which is a financial system where people could like actually say, you know what, this sucks and it's not my fault and I could get out of this. And so that means like a lot of people started basically had companies outside of the country, worked remotely, and then got paid in crypto, and then would would pay themselves from that company and kind of like spend as they needed. And so it led to like massive amount of crypto adoption. And then people started, instead, because there's all these kind of capital controls in Argentina, there used to be, people couldn't like really, there were like multiple different prices for exchanging the Argentinian peso to the dollar. There's like the official exchange rate, but like then the real exchange rate and so on. And so people started using crypto and stable coins massively. And so this led to somewhere between 10 to 20% of the country not just using crypto, but like having like their main savings in crypto, which is huge for any country, right?
Wow.
The second thing that happened is that, super fed up with all of this, the Argentinian people elected Milei, Javier Milei, who is a kind of like I think the first libertarian president in the world, which is like super cool, super interesting. Like I don't personally directly classify myself in any political box because I just kind of like I'm allergic to that, because I think in general like the box tends to like move in places where like you're not. But I think it's really interesting whenever there's like a new paradigm that suddenly starts able to be tried. And I think there's a lot of like really interesting libertarian ideas that should be tried. And but anyway, so he's like, the first libertarian president, and he was kind of like a third party candidate that ended up like galvanizing a lot of people and kind of like just called it like it is and got elected. And one of the first things that he did, well, first off, he like fought really hard against inflation and has managed to bring it down, which is like a huge result, like an amazing result that like inflation has gone down tremendously. Huge result for Argentina, like super promising. Like people are like over the moon over the success rate here. The second thing is that he, because he's very libertarian, he aligns with the crypto ethos. He's not very crypto savvy himself, but he aligns with the crypto ethos of, hey, you should be able to like choose whatever currency you want to transact, and you should be able to like have your, you should be a competition of currencies, and like the market should figure out like what's like the right thing to do. And so one of the laws he passes is he enabled anybody to transact in whatever currency they wanted, which is a huge open door for crypto. Suddenly you now could use stable coins or whatever cryptocurrency you want to transact in Argentina. And so those two things, like both the massive adoption of crypto in Argentina and suddenly having a top-down administration that is like aligned with the crypto ethos, created like kind of like the perfect conditions to like rebuild the financial infrastructure of Argentina that Argentina is missing with the crypto primitives, right? So like I mentioned, there's no good mortgages. Hey, that's like very close to the DeFi loan systems that we've been building for the last 10 years. So like you can take the existing DeFi primitives that we have today and create a mortgage product on top of those, and now like be able to like provide it in Argentina, right? And so like it's just like this amazing opportunity for this like great product market fit opportunity for all of the infrastructure that we've been building, plus actually helping 46 million people get into a much better economic infrastructure like very quickly. And so the kind of like opportunity became like, wow, if we could figure out what those economic primitives are that are missing and help draw attention to founders to go solve them, because kind of like the way that these things get solved these days is that you build good products and like a startup around it, and you go and like commercialize the thing, kind of like the Airbnb example that I gave earlier.
Yeah.
And so we need like 10 to 20 Airbnb type things,
right,
along these specific problems. And kind of like what you need for that is to like just enable a lot of founders around the world, or in Argentina specifically, to go tackle those problems. And so we decided to like start a movement to do this, and the movement is called Crecimiento. And so we like decided to host a pop-up city called Aleph in Buenos Aires. And so we had like the first one was in August, and it was a huge success, like amazing turnout from a lot of people. We had like a month together to like talk about all these problems, talk about like what are the key problems to solve, like how to help and support the startups and the founders. And then we had another one just now in December, huge success as well. We have another one coming up in March, and so there's like this huge amount of momentum in that in this movement to like try and restructure and revitalize Argentina's economy using all of these crypto primitives. And kind of like the opportunity here is like kind of like in the worst case, this will like help generate a huge amount of like high quality products, some of which might get product market fit. It'll also help train tons of builders and tons of founders in how to build companies, and it'll kind of like increase the adoption of crypto, and it'll increase the kind of like general kind of like economic literacy of a ton of like many thousands to maybe millions of people. In the best case, we can rebuild the macro economy infrastructure of like a major nation state and have the first crypto native country on the planet, which would be like a huge result, right? Like if we got like the first crypto nation actually in place, this would be like a massive result. And so I think like that is kind of like super inspiring to a ton of us, and so like that's what kind of like we're working on it. And so maybe like if any listener out there is like vaguely interested in these kinds of problems, or is working on them, like definitely come out to join us there. Again, the next one will be in March, and there'll probably be other stuff happening later in the year that we can't talk about yet, but like there'll be other moments later on. And yeah, if people are working on like core, like, you know, from my perspective, crypto has been this great force of democratizing access to financial primitives and democratizing access to like economic constructions and whatnot. If you want to like help increase that and broaden that access, like this is a great place for you. And specifically, like I see a lot of crypto founders and crypto startups struggle with adoption because they're trying like this uphill battle in economies that are very well developed already. Like if you want to bring like a new way of doing mortgages to the US or to places in Europe, like good luck. Like there's an already massive amount of competition. Like your solution is going to be maybe a few times better, but not 10 or 100 times better. And so you don't quite have like the hair on fire problem that you need to like find proper product market fit,
Right.
especially when your product is new and whatnot. And so this is like a huge opportunity where like the market is there and like needs these products. And so now we just kind of like need to help bring the founders and the startups to it, which is very weird. It's like usually the opposite. Usually you have a supply of founders and startups that can't find product market fit. This is the opposite. You have like a rife set of problems and opportunity space, and you kind of like bring people into the into the community. And then the other part here is like, sorry, good.
No, you go ahead.
The other thing I was going to mention is like, one of the things that I'm excited about there is like deepened networks are a great way of creating jobs because it can enable a lot of people to be like self-entrepreneurial and, you know, provide resources. Like one of the things that I was really excited about in terms of first starting to make Filecoin is to like enable people around the world to like do something like really useful for the world and earn money from it without having to ask permission from anybody, like just be able to like do it yourself. And so I'm super excited to like bring Filecoin to the community in Argentina. It's already has a strong presence there, but like it'll grow through that. And other deepened networks, like, you know, I'm pretty excited about Glow, for example. Glow, where Glow is like a way of like trying to do solar, like try to develop, deploy, and scale solar farm production. And so being able to like do that in Argentina, I think would be huge.
Yeah, huge Glow fan here myself, actually. I think it's just like the right mix of like altruistic, better for the world, and maybe you should, you know, be rewarded for doing that. Anyway, I think that's great. The other thing that, you know, my team, we talk about sometimes is like, there's so many nations, countries, or, you know, that are sort of like pretty interested in a crypto, you know, economy in some way, shape, or form, but like either through like active you know, policy making against it, or just like legacy policy making that just doesn't jive with like how crypto works. You know, they literally can't in some instances, and they're kind of like you talk to policymakers in these different countries, not me personally, but folks on my team are saying like they're literally waiting for a good example where they can go, oh, okay, that wasn't a total disaster. Like, you know, it worked okay here. It worked in Argentina. It worked. And so we can start to update our policies to reflect that. And that's also a pretty exciting opportunity, I think. It's just like,
Yeah,
it is probably going to end up being some floodgate moment where like 3 years down the line, 5 years down the line, when everybody goes like, oh, actually the economy here turned around. Not only did it turn around, but like it worked. Then other nation states can go like, oh, okay, wait a minute, maybe we're over regulating or under.
Yeah, totally. And look, I think that's already sort of happened. It's just that it's happened in ways that governments can't really admit it because it's either something they today took a position against. So
Right.
the one example of that is in the US, where crypto is like a dramatically better way of like moving around money and doing payments. You know, it's dramatically better than ACH or things like that, and way better for capital formation. You know, the fundraising structure in crypto is like dramatically easier, and so that unfortunately U.S. policymakers in the past took positions against, except for like a few really great. Like there's some amazing crypto positive policymakers in the U.S. that are now getting to like actually run at this, which is I'm super excited about it. Like I've been kind of like waiting for this moment for like, you know, 4 to 8 years. But then another example of this is like the places with high inflation. So, you know, Argentina in the past administrations that were kind of like printing massively, or Turkey that is printed an enormous amount, got huge amounts of inflation. In those places, crypto has greatly succeeded. It's just that it's directly counter to like the policy of the government, so they can't quite admit it. And so I think like, yeah, to your point, we need something that is fundamentally not a financial instrument, or not a financial instrument that the government has an opinion on, or a strong opinion on, so that you can then let the success be something that then a government can be like, hey, look, this is like a great success. I think Glow could be that, right? Like if we get to a point where suddenly we're starting to like have something like 5 to 10% of the new solar being put in through Glow, like that would be enormous. Like that would be like a huge tipping point moment where people go, wait, hold on, like this is like a huge effect. Like what's going on here? So I think that could be pretty exciting.
Yeah. I mean, capital. Yeah, like independent capital movement towards like an important environmental cause. Jesus, that's like, yeah, it's huge unlock. Okay, we're gonna wrap it up. I think. I mean, we could go on for hours, but it's probably getting a little bit late for you anyway. So, we're gonna finish it off with what projects, personal projects, or sort of like developments you're most passionate about, like right now, or you can do that one. Or I mentioned at the start of the hour that fellow colleague whose name I'm not going to give you said you're really good at the 1-5 timeline thinking. So do you have like, how do you approach that kind of planning? Like, do you use like a framework or a methodology for that, or is this just like, yeah, kind of?
Yeah. So like maybe on the project scale, I'll talk more about the time one, because I think that's one that I think is like maybe going to be more interesting or more useful to listeners, because maybe they hear about this sort of thing less. On the project case, I'm just spending a lot of time trying to play around with different AI tools and LLMs and whatnot. I kind of like got my start by just programming a lot and developing things, and shipped a lot of open source libraries along the way and whatnot. And then over time, as I started building projects and running a company and running teams and so on, became more of a manager, and like I became like a manager of a manager of a manager. Like suddenly, like I got like pulled away from the code, and that like really sucks. Every once in a while, I kind of like break down and have to like go and build something and like program a thing. Like I think like the last one of these, maybe not the last one, but like one of these was like a new events booking thing that we now use in a bunch of places. But I'm looking forward to like re-entering actually code productive landscape with leveraging LLMs. And I'm not quite there yet, but like I kind of like want to try doing this again. Which is kind of like a very different kind of like like return to the Back to the Future. Sorry, I guess Back to the Past in this case. But the thinking about different timescales thing, I think, is super important and super valuable, and I think is the sort of thing where like anyone can do this. It's just very unusual, and it's not taught, and there's all kinds of pressures against it. So the world as a whole is orienting you all the time to hyper focus on the present, and to hyper focus on the next few weeks, the next few months, maybe the next couple of years at most. Everything from like how school works, you're thinking about like the current day, the current month, the current year. Maybe you think a bit about like the next few years. Maybe like college planning is like one of those things where like suddenly you start thinking about the future is like a weird exception. But for the most part, everything is like very short-termist. Companies are like that. I think early days of startups are more future oriented because you're building something new, so you get to like play around and thinking about, imagine a new future, and you get to like play what if a lot, and you think about the possibility space. But as you build a product and you ship it and you scale it and you get users, and especially once you kind of like enter like larger scales of success, everything again hyper focuses on the present. And so all of Wall Street is hyper focused on the present. And there's this expression that I personally like super disagree with, which is like the everything is priced in the market. Like I just think that's completely utterly wrong, and it just completely misunderstands what the market today is. Maybe everything is priced in a hypothetical market, but like certainly not the markets that we're in. And a good example of this is like the robotics like nobody's priced in like all the robotics manufacturing that's about to happen and all the humanoids that are going to be built. Like that's just kind of like not existing. And so it just shows an example that like millions of people, billions of people around the world, including at like the top levels of decision making, are hyper focused on the present. And so it's kind of like very unnatural and weird to force yourself to not do that. And so what I try to do is, and maybe I'll describe like maybe the practical outputs later, but I'll describe kind of like what I tend to do first. I try to just explicitly spend time out of the present. And what I mean by that is I spend a lot of time explicitly reading history from like different time periods, written by people in different time periods, watching movies or TV shows or YouTube videos, explainers of like different points of time in history. Like I'm a huge avid history like buff. Second, I like read a lot of sci-fi, and I really like thinking about or different kind of like novels or fantasy or whatever that like think of like different conceptions of the world and like really kind of like add a lot of entropy and like think about like different possibility space. I read reports from people or like roadmaps, or there are like a really a very like special source of like inspiration is there's a lot of people out there who have written very interesting visions of the future and like turn them into roadmaps or turn them into like documents so you can go read about what things could turn out to be. And so I try to like spend a considerable fraction of my time thinking about other time periods, like not the present, explicitly to counter this like hyper short-termist focus that the world has. And so it's like one thing. The second thing is I employ this like very valuable principle that of kind of like back calculating from success. And probably the group that popularized it the most, I don't know where it comes from. I think it's kind of in like, it's one of those things that like maybe has come up and been reinvented many times over the ages, but like it's kind of counterintuitive. Most teams tend to forward calculate from where they are. Like you take stock of where you are, you think about improving your trajectory, you set ambitious goals, you like try to crank them up a bit, and you like then measure where you are. But you can often miss success entirely because you just were never going to be on the right trajectory. And instead, if you like visualize and imagine success a few years from now, so like 5, 10, 20 years from now, and you back calculate from that what needs to happen in order to like for it to conceivably succeed in 10 years, what does that mean? So like, you know, how many users does this mean? Like, what have you shipped? Like, what is the product? Like, whatever. And then you just interpolate and you say, okay, great. Like, if that's 10 years from now, what must be the case 5 years from now in order to get there? Like, what's like a good range with like, you know, conservative estimate? And so, you know, if you want to end up with like, I don't know, 1 billion users 10 years from now, then probably 5 years from now, you should have like probably 10 million or 100 million or 1 million, depending on like what growth trajectory you think you can hit, like whether it's going to be easier to get to 1 million or, you know, some products are easier to go from 0 to 1 million and other products are harder to go from like, you know, 1 million to like 100 million or to 1 billion. And so like, but certainly you shouldn't have like 10 users 5 years from now, because like that'll be like a super hard growth trajectory from then on. And so it just like helps you kind of like concretely set goals for yourself along the way, and it helps you kind of like plan out the future. And then maybe the third thing that I do for this is like, I tend to spend a bit of time every year kind of updating on where major technology trends are going. So like I spend a bit of time looking at like different fields, different results. I read a lot of abstracts of papers. I watch a lot of explainers. And I kind of like go like field by field. And I try to think through common cases in other time periods of similar kinds of trajectories, and I try to like kind of like plot, like really kind of like imagine or think through like how long certain things may take, and I try to come up with like some kind of high confidence estimations of certain things. Like one thing that I did recently was like I spent a bit of time thinking about, you know, the manufacturing of humanoid robots as an example, and you know, kind of like what's realistic. Like I think it's very unrealistic that we'll have, you know, 0 humanoid robots manufactured by 2030. Like I think that's the case today. Like we have a few manufactured in labs, but none of them are like in real production. Yeah. And I think the likelihood that we'll have 0 in production by 2030, I think is like close to 0. Now I think like 1 billion seems extremely hard. And so, there's somewhere in between that like is more realistic. And you can look at like the software trajectory, you can look at the hardware trajectory, you can look at several companies, and you can sort of like start plotting out like what's likely to happen in that time frame. And you can have like higher bars. I think I did a Twitter poll on this like recently, and just to see what other people thought. And you can learn a lot by like getting what other people think. But kind of like the figure that I ended up with is like we're probably going to be somewhere between 10,000 and 10 million. That's like a high bound. If I had to have a higher, like a tighter bound, it would probably be something like, I think it's probably closer to 10,000 to a million. I think that's more likely in 2030, but I'm not sure. But that means like already like 10,000 or a million humanoid robots in production by 2030 is like crazy. Like that means like you'll see them on a regular basis. That's like more than like the number of like self-driving Waymos that are out there today. So like that starts putting these things into high production use and starts reshaping how society works. And that means like it opens the door to all kinds of problems and whatnot. And so if you just, I don't know, do this over like a few different fields and a few different like trajectories, you can then start intersecting things and seeing like, oh, wait, hold on. Like these two things are going to intersect in like this crazy way. And that's going to open the door for like a bunch of other possible things. And so like that's, yeah, I don't know. And then I don't know, at least in tech, you get to, there's these like acceleration of progress curves, like the Moore's law type things that are just keep on giving, and you can just plot them and see where they're going to head. And one of my favorite graphs on this, and what I think is like probably maybe humanity's like most important graph, is a plot of like the computational complexity increasing over time, and like kind of like predictions, and kind of like estimates over time, plotted against different models of what it would take to like emulate a whole human brain. So that means like if you were to scan a whole human brain and then simulate it in a computer, and emulate it, like what level of computational complexity would you need? Well, that depends on like what structure of a model you use to represent the brain. Like if you figure out and you solve how the brain works, maybe you can like develop functional units. Or if you then have to scan every neuron and every synapse, then you have like the synaptic connectome. Or if you say, no, there's actually like way more channels in between the neurons, and we have to like capture all of the electrophysical interactions between each of the neurons, then that's like a harder computational complexity. No, actually, we have to like model all of the neurons themselves, like their internal processes and like the proteins going on. Like that's like a dramatically like higher level of computation that you need. And so if you like plot these different assumptions, and then you like just see where like computational power is going to go, it just shows you that depending on the model that you pick, we're going to be able to do this by 2040, like 2035, 2040 is where I think it's like most likely. It might take longer if we end up finding out that like, I don't know, maybe it turns out that like Penrose was right, and like the microtubules in the brain actually do something like really important, very low likelihood, but like it's possible. But if we can like figure it out, if the brain is like very classical, which is where like the dominant, most people in neurotech think this, then we should have it by 2040 at the like outside of a kind of conservative guess, which means that it's probably possible to do in the 30s, like early 30s. So that means that like probably if people worked super hard on this, you could do it even sooner, like in a Apollo style program level. So you could get into like human emulations sometime between 28 and 35. And so like and all of this drops out of like just the looking at the curves and where they're going, thinking about the other technologies. What are the things you have to invent to get there? Like what are the recording methods that you might need? What are the, and so on. So you can like just keep like looking at the tech tree, and you can end up with something like this. And so I think like that's kind of like the set of things that I do to help me think about different time periods, and like, highly recommend folks like do this and like develop your own opinions and test them, like make predictions. And after like 5-10 years of doing this, like you'll get like dramatically better, and you'll be able to like predict the future much better than other people, which is a super advantage. Like I think it's like helped me tremendously to be like, and look, it's not like I can foresee things. It's rather like I have like some bounds on like what I think is likely to happen, and it's been very, very helpful and useful in plotting trajectories, and it's helped me be ahead of the curve on a lot of things. Now other people do this dramatically better than me, which is why I would love to have a market where I can just like pull them, and which is why I want prediction markets to work.
Right. Yeah.
But yeah.
Yeah. A couple of things you said, I was like, yeah, man, it would just be nice to have a bunch of people who had opinions about, whether we're going to have 10,000 or 100,000 or a million, humanoid robots walking around, and just do a prediction market. And some of those people have no idea, but are willing to invest some effort. And some of those people are robotic scientists who have strong, incentive to really actually use their, use their knowledge to predict. And yeah, anyway. Awesome. That's a great way to finish up, for a view to the future, and why crypto can maybe help us figure out what it's going to look like. This has been really fun. Hopefully it's been fun for you as well. We'll have to catch up in person at some event soon. For any listeners, Juan will try to put some of the links to your next couple of pop-up events in the show notes or whatever it is that we do. Yeah, thanks for hanging out.
Yeah, thanks for having me. This was an awesome conversation. Like, really excited that you're doing this. I think it's like a great idea. Really looking forward to all of the next conversations you're going to have, and to listen to those. And for listeners of this one, if you're curious about some of the references that I made or that we made along the way, if you have like a question or whatever, just drop it on the tweet for this broadcast, and I'll check that over the next couple of days. And if there are any questions there, I'll like post links. Thank you so much. This was really, really fun.
Thanks, Juan. Cheers.